Hi, everybody. So in the next 25 minutes, I'm going to be talking about advanced React patterns, and I'll try and do that in very plain, approachable language. Okay. So this is me, and currently I work as a senior front-end engineer at Omeo, where we try to make travel really easy across Europe and all over the world, to be precise. And I happen to write a lot these days, and I have been for a while, and I'm a published author as well. And during these times, I just dance and listen to music while I quarantine alone in my house. Okay, so let's get right into it. So here's how this talk is structured. First, I'm going to introduce all the patterns. Well, don't let the advanced in the topic, throw you off. Some of the patterns are really, really simple, but these are patterns that you can apply to whatever component you're building, and they're going to make sure that you have a much more reusable component and something that it's a delight to work with. Right. So after I introduce each pattern, I'm going to show you a basic example. And after the example, we're then going to explore open source community examples, just so you can have a view of what other people are doing. And afterwards, if you've got questions, you could write them in the chat, and I'm going to answer all of them after all the talk. Great. So now let's see the first pattern that we're going to discuss. And this is like the foundation of everything. And this is custom hooks. I'm pretty sure that you have heard about or used custom hooks before. So I'm going to run through this really fast. But this is the foundation of everything. And now custom hooks really just help you reuse stateful logic within your components. And a basic example is this. Typically, it's just a function that you could call anything, but it's got to start with the use. And then within that, you can go ahead and isolate all state and effects within that function. And then you can go ahead and call this wherever you want, with the assumption that you are doing that in a React functional component or another custom hook. Pretty simple. So now let's see what people are doing, what the open source community are doing. So the first example is React use. Now, the use of custom hooks here is pretty much how you would expect. Okay, so they have small set of functions that do one thing, and then they export a lot of these functions. So you as a user can import all of them, one or more of them, and use them within your app to do whatever. So here's an example. You've got something called useEffect once, and that is just a modified useEffect hook that runs just once. And you have stuff like useEvent, and that helps you subscribe to events. And you've got usePromise, which just helps you resolve promises while the component is mounted. Now the takeaway here is you can go ahead and do the same with whatever component library you're working with. It could be at work, it could be wherever. You could just go ahead and isolate really, really small functions, and so that you can move that all around and reuse them as much as you want. Now let's take a look at a more interesting use case. And this is React Table. It has to be one of the most popular libraries for creating tables with React. It's got over 10K stars, but it takes a very interesting approach to custom hooks. Now, historically, if you wanted a UI component, you would expect that the library exports that in UI components, some elements that you can compose together and make your UI. But React Table takes a very different approach. As opposed to exporting UIs, it does export just custom hooks that return certain values, and then you go ahead and build your own UI based off of that. Now, this has some disadvantages, but it's a very interesting take. And I'm going to go back to this later just to show you what they're doing and how this is possible. Now, with custom hooks, this has a couple pros. Pretty simple. You've got single responsibility models. These are very testable functions, and then you can move them around and reuse them all across the place, anywhere you want. And in the case of React Table, what I like about it is this reduces complexity. For example, earlier versions of React Table did have UI components, and these components had like over 30 props that you could pass into them to customize them. And then they took a different approach in the later versions and just killed all of that and moved to custom hooks that are way more simpler and let the user bring their own UI. And that is a disadvantage of its own, because most people expect that you give them the elements that they're going to use and all the visual part of it, and not just some functions or modules. But there is a reason why that works as well, and we're going to take a look at that later on. Okay, so that's it for the first pattern. Now let's go further and see a more interesting pattern, and this is a compound components pattern. Now this is pretty simple, but very exquisite in its own, because it lets you explore the relationship between UI components as parent-child explicitly, and then within that structure, within that tree, you can go ahead and share implicit state. Now here's an example. If you were going to build a component that showed some clap, some animation with some details, a number of claps, what you would typically do is just go ahead and render one B component, and you have all the logic and you have all the UI elements and components all in that, and then you go ahead and export that to the users and they use this. While this works, what if you go ahead and did something different? As opposed to just exporting the parent, you go ahead and export all the chat components so that the users can compose the UI themselves. While this may seem like it's more work, it does have some advantages as well. Now, if you take a look at this, you'd see that the example here has all the chat components appended to the parent component, much more like they are added to the instance of the parent. That is not compulsory. For example, this is equally valid. You could go ahead and have the parent and just export all the chat components and just compose all of them without having to append them to the instance or attach them to the instance of the parent. Great. Now, why is this important and why is this helpful? The reason why this is really good is because you have your UI state completely managed by the parent, and you can communicate that state through the component tree via something like the context API. And this gives you lots and lots of flexibility, which we're going to take a look at. For example, here's a library, Rich UI, which has over 3K stars, pretty good. And let's consider how an accordion component from Rich UI is used. Now, as opposed to just giving a single accordion component, which will have all the logic and all the related UI components, what Rich UI does is slightly different. It gives you the parent and it gives you all the chat components as well. Okay, so you go ahead and import all of that, and then you use it like this. You go ahead and render the parent, and you render the specific chat components in whichever way you want. Now, why would you do this? Why do you have to do this much work, and why is this helpful? Here are some pros to doing this. One is you have a flexible markup structure. Now, when you do this, the chat components can be moved wherever, whichever way. You could say you don't want the header at the top, and you want it down, and you could go ahead and move that any way you want. Also, the users don't have to use all your chat components. They could go ahead and write whatever element they want to write within your parent component, and it's all going to work. So this gives very, very flexible markup structure to the users of your component. And secondly, this helps you reduce complexity. Now, if you had one giant component, what typically happens is you're going to have lots of props being passed to that, and then within your internal implementation, you go ahead and forward all of that to the chat components. While that is not bad in itself, it just makes your implementation a little more complex when you could go ahead and split it up, have things more semantic and way more simpler. Okay, and third, you have a separation of concerns that is really good for architecting good software and good components. Great. But what are the cons to this? Like I said before, you've got to do a little more work. While you get a lot out of it, I think the work that you have to do is minimal, and it makes up the advantages make up for it. So I would say that this is a great pattern to use if you've got a large component that you can break down and have some sort of child-parent relationship. Then you should go for this. This is a beautiful pattern to simplify how you export your components. Great. Now let's go over to the third pattern we're going to take a look at. This is very, very simple, but it does help a great deal. Now, regardless of the component you build or the components you use, there's got to be a way to override and add new styles. Now, how do you do this? There's a variety. There's a lot of ways you could do this, but here's a core principle we're going to work with. You want to make sure that your users can style your component like they would any other element or component. For example, with a typical JXS element, you can style them with a class name or a style attribute. So if you build your component, you want to make sure that that works. You can pass a class name and it works. And you want to make sure that this works as well. You pass a style property and a user should be able to override or add new styles. Now, what about CSS and JS solutions? So if your users want to use style components, or they want to use emotion, or they want to use glamour, what about that? Now, if you handle the previous cases where it's possible to override styles by passing a class name or a style prop, most CSS and JS solutions are going to work as well. So it doesn't matter which solution they're using, it's also going to work. So as long as you do that, you accommodate for all other options. Pretty simple and pretty powerful as well. Great. So now let's take a look at what Rich UI does, which is the library we took a look at earlier, which contains a lot of components to make UI building more accessible and easy to work with. And now here's what they do. Here's an example from Rich UI. You've got this menu list component, and as you can see, it can't be styled with a class name prop. Great. It can't be styled with a style prop. Perfect. And if you're using style components or emotion, it works perfectly. And if you're using glamour as well, it works perfectly. Now, if you're building a component and you need styles to be shareable, extensible, or reused, or even just extended, then this is something you should work with. You should make sure that the users of your component can style your component just like they'll style every other element or component in their app. And you'll be providing a much more simpler and easy to use pattern. Great. Now let's take a look at the third, not the fourth pattern. And this is called the control props pattern. Now, when you had control props, if what came to your mind was, oh, I've seen this somewhere, that's React controlled elements or React controlled components, you're right. Now, control props allow the users of your component to control the UI state you've got internally via some control props in code. Okay, so what are these control props? Typically, if you have a component, what we're talking about is being able to pass the state value and a state updater to that function, the component in this case. Now, this is exactly what you do with an input, a controlled input, for example. You pass the state value and you pass the state callback as well. Okay, and the callback goes ahead and updates the value at any point in time, and you have this controlled component. Now, why this is important is there are cases, even though you handle a lot of use cases internally, there are cases where your user wants to do something else, okay? And as opposed to having complicated logic and how they should do this, you could just go ahead and make sure that your component works like this. They can pass a state value, all values, and they can pass a state updater. And everything's going to work perfectly. Now let's see what other people are doing. Here's Material UI, which seems to be really used in the community. You've got about 56k stars. And let's take a look at one of the components. This is a rating component, okay? Now, how does this work? In very simple terms, you just go ahead and import that component, and then you put a name on there and a default value, and this just works perfectly. Now, when you do this, internally, the component is going to handle all the states. You don't have to worry about anything. They're going to do all of it. Okay, as soon as you click, the rating is going to go. Perfect, that works. But what happens if the user wants to control that state themselves? Now, this is where control props come in, and this is what they do pretty good. Now, you have the same component, but they make it possible for you to pass a value and an unchanged callback. Now, in this case, value stands for the state value, and unchanged stands for the state updater. Okay, and when you do this, you have a completely controlled component. But how do they do this? So internally, what they do is before you go ahead and update state internally, you've got to check if that component is being controlled or not. If it's controlled, you go ahead and return the user's state, or you go ahead and do what you should do normally internally. And the same goes for the updater as well, the state updater. You want to go ahead and check if it's controlled. you go ahead and just call the user's callback. And if it's not controlled, you go ahead and do what you would have done internally. Anyway, great. Now, by doing this, while it looks really simple, you leverage an opportunity to make sure that you don't overcomplicate the what's it called now? You don't go ahead and overcomplicate the implementation that you've got internally, and just make sure that by exposing these simple props, you can have the state of your component managed externally by the users of your component. Now, what are the pros of using this pattern? Now, while it is super simple, it has to be the simplest way for you to implement the inversion of control. Okay, so if you don't want to control what's happening on the inside of your component and want to make sure that the users of your component are taking care of that, this is the easiest way to do that, hands down. And what are the cons of this? It is possible that while you do this, while you cede control over to the users, there are cases where the user is going to have to duplicate all that you have done internally. Because, for example, take a look. You have a callback that does something internally. Now, when the user decides to override that, they're going to have to do something as well. In most cases, they want to have an addition to what you're already doing, or they just want to have a tweak. Okay, but if you expose this pattern, all you've got to do, or the user's got to do, is pass a new function. And by doing this, there's a big chance that they're going to have some duplicates in there. But as we go on, I'm going to show you another way to avoid this. Great, now that is it for that. Now we're going to go on to the next pattern, which is pretty interesting. And it's called the props getters pattern. And what this does is really simple. We want to make sure that we can provide a collection of properties to the users of our hooks or component. Now, here's what I mean. Most components are going to have the same set of props being used all over and all over by the same set of users or different users. It doesn't matter. But as long as people are using these components, you as the builder, you as the champion of the component, you know that the users of your component are going to need these props. Now, what you can do is go ahead and provide that beforehand. Now, here's an example. If you build a hook, say use your hook, and then that hook gets invoked, what you can do is go ahead and return a function that returns a collection of props. In this case, the props collection could be just an object of key value pairs that point to specific properties that could be passed into some elements by the user. Here's an example. So in this case, the user could go ahead and just invoke the function that you return from your hook, get props collection. That gets invoked, and because it's a function, the user as well could go ahead and override whatever you've got in there. So for example, if my collection returns an on-click key that points to a value internally, the user could go ahead and override that with their own specific handlers. Now that's why using a function here makes a lot of sense. Okay, now let's see what other people are doing in the community. If you take a look at React Table, I did talk about how easy this is, because now they offer just custom hooks to build out table UIs. Now, while that is tricky in itself, the reason they're able to do this is when you invoke that, the hook, for example, use table, they go ahead and provide a couple prop getters. Now, what happens is, these are functions that you go ahead as a user and invoke, and that passes automatically. You get some properties that just gets passed on to that element without you having to do anything. Now, if you combine custom hooks and prop getters, you can see how React Table can go ahead and not provide any UIs at all, and the user can still go ahead and compose their own tables. Now, this comes with a lot of benefits, and one of it is this flexibility. The flexibility and ease that you provide to your users makes this pattern a very beautiful one. Now we're going to go ahead to the next one. This is called the state initializers pattern. I like this because of its simplicity and how useful it could be. Now, this is simple. All this pattern does is make sure that you provide a way to make sure that the initial state of your component is configurable, and you could provide an optional state reset. How does that work? So here's a basic example. Let's say I've got a hook called user hook, and I make sure that my users can pass whatever initial state they want to pass, and I go ahead and return something, but what I return as well should have a reset handler to make sure that the users can go ahead and reset the state. Now, internally, as soon as the user passes the initial state, I go ahead and pass that on to my internal implementation. For example, I could call setState or useState and pass that on. Whatever the user passed in, I pass that on to my own internal state mechanism. Great. Now, if you took a good look, you'd realize that what we're doing here is we're taking props and passing it down to state, which is generally frowned upon for very good reasons. And that is why when you do this, or if you do this, you want to make sure that the state is not dependent on props, but what you pass in here is just an initializer that is just used once. Okay, you're not having derived state, which is a bad idea. Now, let's consider Formic. Formic is a popular library for creating easy forms in React. Now, here's a very simple example. You go ahead first and you import the Formic component. Pretty simple. But that component lets you pass in some initial values. Now, the initial values you pass in here are going to be used internally as the initial state for that component. What's interesting is how this is handled internally by Formic. Now, Formic goes ahead and saves all these values into ref objects, the initial values. Now, by saving into a ref object, this pretty much acts like instance variables. By doing this, subsequent changes are ignored. So this is not derived state. You have an initial value that is passing by the user, and you go ahead and save that and reuse that all the time across the same renders. Perfect. Now, Formic as well is kind enough to go ahead and expose a reset function. And that reset function is what the user calls if you want to reset the form to initial state. And that initial state could be the initial values that you passed in the beginning. Great. This is a really, really simple pattern, but it does have some very important pros. And first is that the ability to set state first, the initial state, and the ability to reset that state is pretty much a very important feature for most UI components. And so if right out of the bat you go ahead and do this, you're going to be helping your users of your component. And secondly, this is super easy to implement, so why would you not do it? And the cons is, depending on the component you're building, this may be super trivial and probably not worth the effort for you, but regardless, this is a perfect pattern because it's such a widely requested feature. Great, now let's take a look at the last pattern. This is a little more challenging to explain, but I'm going to do my best. So here it is. First, the state reduces pattern, very much like the control props pattern, is there to make sure that you can cede control over to the users of your components. Now, this goes a step further. To prevent duplicates, you can also go ahead and export action types. Now, I'm going to show you what I mean, but here's a very basic example. So if you've got a hook called, say, user hook, now you want to make sure that the user of your component can pass a reducer to that hook, and that reducer is what's called the state reducer by itself. Okay, what am I talking about? Okay, wait, let's take a look at a very interesting example. Here's downshift, which helps you build really interesting form, not really form, but input, React inputs. It could be autocompletes or whatever, but this helps you build all of that. But here's how it works. When you import the component, you can, this is not necessary, you can pass in a state reducer. Now, and this reducer is basically just a reducer. It's going to take state, and it's going to take the proposed changes that downshift, the component, was going to make internally. It's going to pass this on to that reducer, and it is the reducer's responsibility to return new state. Now, why is this interesting? This is so interesting because every single time that the component is going to set internal state, the reducer is going to be called. Now, and if this reducer is passed in by the user, it means the user has complete control over the new state of the component. They could go ahead and update the state or not. And this is complete control you're giving to the users, and this is perfect for that. Now, here's a more interesting use case. Now, what downshift does is export types. What this does is that for specific types, your users, the user of your component, could go ahead and say, well, I don't care about this type. I care about this type. And if this type comes in, just go ahead and ignore all the changes. But this specific type, go ahead and do this. Now, by doing this, you can eliminate the need for users to duplicate code you've got internally, because they're just going to do the default that you would have done internally by using types. And they could go ahead and indeed have maximum user control. Now, why is this important again? This gives you users the ultimate inversion of control. Unlike control prompts, this takes it much more to the next level and gives the user the control to do whatever they want, because they're passing a reducer and you call that reducer every single time before an internal state update is made. But this doesn't come without its own cons. And the con of this is basically, this is perhaps the most complex of the bunch to implement, because it's a little more technical. But if you get this done, you will be doing the users of your component great good. Okay, and that is the last pattern we're going to take a look at. And that's all of it. And I thank you so much for giving me the past 25 minutes and listening. I hope you enjoyed it. So the next steps, I would expect that you go ahead and use these examples. If you're building a component library, if you're building something within your company, or just personally, just go ahead and try these patterns. They're amazing, and they're going to help you have very solid patterns, very solid components rather. And you can let me know what you think about this, all the patterns I just talked about, and you can reach me at Ohens Emmanuel on Twitter, and I'll be super glad to hear from you. And also, do not forget to stay safe. These are trying times. And if you want to see all these patterns, what I did was write up a 20-page booklet that shows all these patterns and how they're used in the real world, with lessons from open source community libraries. And that's the URL where you could get it. And it shows you some really cool examples from libraries like Reactable, Rich Router, Downshift, Formic, etc. Okay, so thank you, and thank you all for having me. Bye.